Hi there. Section 1.6 is all about subtraction of real numbers. The first thing we have here is what we call the opposite or additive inverse. Now, these two vocab words, you need to make sure you take the time to learn them. They are synonyms with each other, meaning they mean the same thing. So you'll see both of these words referring to this. It tells us here the opposite or additive inverse of 6 is negative 6. That is because both of these values are the same distance away from 0 on the number line, but on opposite sides of 0. Now, anytime we take a pair of opposites or a pair of additive inverses and we add them together, 6 plus a negative 6, right, that's going to be equal to 0. That's going to hold true no matter what our real numbers are. Even something like negative pi plus a positive pi, that's going to also be equal to 0. So the sum of all opposites is always 0. Example 1, find the opposite of 8.3. So you're asking yourself, what number is on the opposite side of 0 that is that same distance away from 0? Right, and that would be a positive 8.3. Again, if you were to add those two values together, negative 8.3 plus 8.3, you should get 0. So we already talked about this. What is the sum when two opposites are added together? Right, it's going to be 0. The next one, find the opposite of x and the opposite of a negative x when x equals negative 3. So we have to do two separate problems here, but we want to use x equals negative 3 for both of those. One thing you always want to keep in mind that anytime you have to substitute a negative value into something, you want to put it in parentheses. So the first one we have here is negative x. So the easiest way to think of this is we're actually going to just take an eraser here and just erase the x itself. But you see I'm leaving that negative out front. Now we are substituting in a negative 3 in place of the x. So you're taking this value and substituting it in for x. Keep in mind, the negative out front here is still right here. This negative is this negative. This negative over here is separate, so we have to keep it separate from that one. Now we want to simplify this. So we want to read it as the opposite of a negative 3. You can also think of this as a negative 1 times a negative 3 if you need to. In the end, if you take a negative 1 times a negative 3, right, you're left with a positive 3 for this one. Now we want to look at the second problem here. We want to take that negative 3 and substitute it in for this x right here. Now I'm going to write the original problem. It's the opposite of a negative x. Same thing. I'm going to just write the thing and then I'm going to just erase. Oops, that was a really big eraser here. Let's go back and redo that one for a second. Let's make it a little bit smaller. Okay, so now, like I said, we want to just erase the x here, leaving both of the negatives. Now we're going to substitute in that negative 3. You'll want to put another set of parentheses and squeeze in that negative 3 there. Now, we want to start simplifying inside the parentheses. So we have this negative outside first, so we're bringing this negative straight down. But now we want to simplify this. So the opposite of a negative 3, right, that would be a positive 3. You can put that in parentheses if you want, but you don't need to, so we're just left with a negative 3. Think of each of these negatives as a negative 1. So you could have thought of this as negative 1 parenthesis times a negative 1 times that negative 3. And you can see if you have an odd number of negatives, your answer should be negative. The next thing here, how can we rewrite 3 minus 2 as an addition problem without changing the result? Right, 3 minus 2 would be the same as 3 plus a negative 2. You can take any subtraction problem and make it an addition problem by adding the opposite. Because when we look at this value right here, this is a positive 2 if we were to cover up the 3, the minus. So we're making that 2 negative and changing that to addition. So now the next set, rewrite each of the following as an addition problem, then add. So instead of 2 minus 6, right, we can rewrite this as 2 plus and then make that a negative 6. And now we can think back to 1.5 when we added 2 plus a negative 6 would leave us with a negative 4. The next one here, we have 4 minus a negative 9. Remember, you have to add the opposite. So we make that addition and then make that a positive 9. What I tend to always do is when I see minus and negative next to each other, I think that it changes to an addition problem like that. So then we're left with negative 4 plus 9, which results in a positive 5. Okay, letter C. Again, we have minus a negative here. So minus a negative just becomes a plus. So we are just adding these fractions. So we can rewrite this as 3/10 plus 8/15. Now, in order to add fractions, we need to think back a couple sections. Right, you must have a common denominator. A least common denominator will help. So we want to think about what is the smallest multiple that 10 and 15 both have. Always start with 15. Does 10 go into 15 evenly? No. What's the next multiple of 15? 30. Does 10 go into 30? Yes. They both go into 30, so 30 is going to be our least common denominator. So now we want to ask ourselves, 10 times what is going to give us 30? Right, and that would be a 3. So we need to multiply this by a factor of 1 of 3 over 3. And then we ask 15 times what is 30? Right, that's going to be 2. So we want to multiply this by 2 over 2. And then continue to work through this. This would be 9 over 30 plus 16 over 30. So then we add the numerators to give us 25 over 30. And we know that will simplify because they are both multiples of 5 here. So I'm going to come up here because I'm running out of space. We know that they both have multiples of 5, so we could rewrite 25 as 5 times 5. You could rewrite 30 as 5 times 6. Now we know since they both have a factor of 5, that cancels, and then we can say this is equal to 5 over 6. You'll notice that my work here, this is how you want to make sure you set your work up. You want to space things out as much as possible. On your homework, make sure you don't cram everything into one little line. You want to space things out and make it nice and tidy. Okay, the next one here. We want to simplify 8 minus a negative 4 minus 2 minus a negative 5 plus 3. First thing I always recommend is change anything that needs changed. For example, if we have minus a negative, we know that's going to be plus. Again, minus a negative, you can change that to a plus. And then rewrite it. So this is 8 plus 4. You can change that minus 2 to plus a negative 2. And then we have plus 5 plus 3. And again, just like we looked at in the last section, you want to make sure you show work here. It doesn't matter the order in which you add these, you just want to make sure you add them correctly. Once everything's addition, you can add in any order, just like because that's what the commutative property allows. So we have, if we just were to do a step at a time, we have 8 plus 4, which 8 plus 4 would be 12. And we have this plus a negative 2, plus 5 plus 3. And you can just keep working through the problem like this if you need to. 12 plus a negative 2 would be 10, plus 5 plus 3. Well, in this last step, we can do this all in one. 10 plus 5 is 15, plus another 3 would be 18. And then what you can do is type the original into your calculator just as you saw it before you changed anything to make sure you did it correctly. Common mistake is we change these incorrectly. Okay, moving on. The next one, combine like terms. This is the same thing we've done before with combining like terms. We just now have some subtractions in there. Again, one thing I always recommend, especially if you're getting little things mixed up here and there, change everything to addition first. That way you can change the order without screwing up anything with the signs. So we have negative 5a. We can change this to plus a negative 7b plus a negative 4a and then plus that 10b. And then we just want to keep in mind that we want to add our like terms. So now we have a negative 5a minus 4a, right, which would give us negative 9a. And then we also have, we use yellow here, negative 7b plus 10b, right, which would be plus 3b. And that would be our final answer. Letter B. Actually, pause the video and try letter B on your own. Okay, so for this one, we know that we have 4 plus a negative 3m plus a negative 9 plus 2m. It doesn't matter which you start with here. If I want to start with the terms that have the m's, negative 3 plus a 2, right, would be a negative 1m. We just write negative m. And then we have 4 plus a negative 9, which would be either, you could write it as plus a negative 5, or you can just write minus 5. Either one is sufficient. Okay, last page we have here is our problem solving. In example 6, in Pennsylvania, the record low temperature was negative 42. The high was 85 degrees. What is the difference? This is something that we looked at a couple sections ago when we were identifying what are the integers that correspond to this problem. So we want to think of it like this. If we have a number line here, and we know this is going to be 0. Now I'm not going to write out that many digits, but we know 85 degrees Fahrenheit, would be all the way up here. Negative 42 would be someplace down here. We need to find the distance from here to here. So we know that this distance right in here would be 42. We know this distance right here would be an 85. Right, so we need to put those two values together and add them. Now, what we want to set up is going to be an expression. We want to make sure we set up something mathematical that corresponds to what we are doing. Now, you could just set up as that plus that. But we want to make sure we set up a nice subtraction problem here. The process that we have to take is anytime you have a problem like this, you always want to take the high, whatever it is, minus the low. So we want to think of it in terms of this problem. What's the high temperature? Right, it's 85. And we need to subtract the low. What's the low? Right, it's a negative 42 degrees. How do you handle minus a negative? Right, that's where the addition comes into play at. So then we have to take 85 plus the 42. And when we do that, we get 127. So the difference was 127 degree difference between the high and the low. What I want you to do now is pause the video and try example 7. Okay, so you can see the first thing is the Jordan River begins at an elevation of 550 meters. That's going to be our high above sea level and empties into the Dead Sea at elevation of 400 meters below sea level. So that's going to be our low. You can see I drew out a little number line here only because it helps me visualize. I need to find the distance from a negative 400 on a number line all the way up to a positive 550 on the number line. Just like we said before, we need to take this distance here, which we know would be 400, and end up adding it to this distance here, which we know would be 550. But first, before we do that, we have to set up the proper mathematical expression, the high minus the low. The high is 550 minus the low of negative 400, which would be, then we want to add those values together to get 950. Again, on the exam, you need to set up a proper mathematical expression like you see here of the high minus the low, or you will not get full credit. Meaning this right here is what I need to see. It has to be the minus a negative in the event you're subtracting a negative value. Even if you get the right answer by default, you will not get full credit if it's not correct. That's all we have for this video. Please reach out if you have any questions. Have a great day.